Well, good day everyone and welcome to the Clean Shipping Methanol webinar. Thank you for joining us. Our moderator and first presenter today is Greg Dolan, who is the Chief Executive Officer of the Methanol Institute. Now, Greg has been with the Institute for the last 25 years and has been their CEO for the last decade. He manages the Institute's offices in Washington, Singapore, Brussels, Beijing and Delhi. And he looks after international governmental regulations, media relations, public education and the Institute's outreach efforts. Now, Greg has presented papers on methanol-related topics for probably over 100 conferences. He's authored magazine articles and written book chapters as well. The first of our other three presenters is Kjeld Arbo from MAN Energy Solutions and Tony Stovczewski from Wärtsilä. After Kjeld and Tony, we welcome Anita Kajdar, who is the Managing Director of ProMan Shipping. Greg will give you a bit more information about all of our presenters as he introduces them. Now, after the presentations, there'll be a panel which Greg will moderate. All of you can submit questions via the chat area for Greg to put to the panel. If I could finally ask everyone at this stage to click the mute button, and I'm very happy to hand over to you now, Greg. Thank you.
All right, thank you, Simon. Let me see if I can share my presentation here. How's that look?
Yeah, spot on.
Awesome, great, thank you. Thanks, Simon. We appreciate that Clean Shipping International has organized today's webinar. We have a great panel today to discuss the use of methanol as a marine fuel. In a moment, I'll set the stage by looking at methanol production, its use as a marine fuel, and the benefits methanol offers. We'll then turn to the engine manufacturer's perspective with two presenters. Kjeld Arbo is Director, New Technology Sales and Promotion for two-stroke engines at MAN Energy Systems, based in Copenhagen. Kjeld first joined MAN Diesel in 1983 in stationary engines before moving to marine engines in 1992. He has led MAN's dual-fuel two-stroke engine development and now has a large number of methanol engines in his order book. Tony Stovczewski is General Manager, Product Sales and Development with Wärtsilä out of Gothenburg. Tony has been with Wärtsilä for 21 years with broad experience in the marine industry for medium-speed engines. He's responsible for marine retrofit solutions, focusing on fuel conversions in the European market. Tony led the development of Wärtsilä's four-stroke methanol dual-fuel engines used in the world's first ship operating on methanol. We'll also hear from a vessel owner's perspective with a presentation by Anita Kajdar, Managing Director of ProMan Marketing, Logistics and Shipping. Anita has over 18 years of experience in the energy sector in Trinidad and Tobago and in Europe. Prior to taking over her current role based in Switzerland, she was Commercial Manager of Methanol Holdings Trinidad, part of the ProMan family of companies, a global leader in methanol production. Anita also serves as a member of the Methanol Institute's Board of Directors, and ProMan now has ordered 6 methanol dual-fuel chemical tankers. As Simon noted, following these presentations, we'll open up to a panel discussion. So as you think of questions during the presentations, please share those in the chat function. So let's begin. By way of introduction, the Methanol Institute serves as the trade association for the global methanol industry, with offices in Washington, Singapore, Brussels, Beijing, and Delhi. This is a listing of our member companies, representing the world's leading methanol producers, distributors, and technology leaders. Our members produce methanol and move it around every corner of the globe. Our membership has been expanding this year as more shippers look at the use of methanol as a fuel. We now represent MOL, Stena Bulk, Maersk, MSC, Oldendorf, and as of last week, Danios Shipping. Now, globally, most methanol is made from the steam reformation of natural gas. Mature technology facilities have produced 5,000 metric tons of methanol per day. In China, they produce much of their methanol from coal gasification. Methanol also can be made from a wide range of renewable feedstocks. Methanol is an essential building block for hundreds of products that touch our daily lives: paints, plastics, building materials, car parts. Methanol also is an emerging energy resource used directly as a fuel for cars, trucks, ships, industrial boilers, cook stoves, and kilns, as well as a feedstock for other fuels like biodiesel and DME. In addition, methanol is an excellent hydrogen carrier for fuel cells. Last year, global methanol demand was nearly 100 million metric tons, which is 33 billion US gallons or 125 billion liters. Over the past decade, methanol demand has more than doubled, with growth led by two markets: methanol fuel use and its production of olefins, from methanol. China is by far the world's largest methanol consumer, responsible for more than half of global methanol demand. Methanol, CH3OH, is made from synthesis gas, a combination of hydrogen, CO, and CO2, and these elements can come from several pathways. Recently, the Methanol Institute released a joint report with the International Renewable Energy Agency, Innovation Outlook Renewable Methanol. This is the first comprehensive assessment of renewable methanol. These days, we all like to color code our fuels. For methanol production, at one end, we have coal-based methanol, which is pretty much exclusive to China and could be considered brown methanol. Conventional natural gas-based methanol is gray. Blue or low carbon methanol will be based on natural gas feedstock with the addition of renewable electricity or green hydrogen and possibly CO2 captured from a neighboring industrial facility to reduce a plant's overall carbon footprint. Now, green methanol can be biomethanol produced from biomass gasification of municipal solid waste or forestry residue, or from biogas produced at landfills, wastewater plants, or animal agriculture. Green methanol also can be made from green hydrogen produced from renewable electricity through electrolysis, plus CO2 from either biogenic sources, flue gases from essential industries such as steel and cement, or in the future from direct air capture. This is often referred to as e-methanol, which is an electrofuel, an e-fuel, a synthetic fuel, a power to liquid fuels. We have a lot of names. Often these two green methanol pathways, biomethanol and e-methanol, are referred to broadly as renewable methanol. Now, the challenge over the next decade will be the ramp up to production of biomethanol and e-methanol to greater commercial volumes. This is a map of current biomethanol and e-methanol facilities in operation and those that are now under development. Current commercial plants and announced projects represent roughly 1 million tons of e-methanol production capacity and 3 million tons of biomethanol production capacity. But keep in mind the methanol molecule CH3OH is the same whether it's produced from gray, blue, or green feedstocks. Conventional natural gas-based methanol can be used in new builds and retrofit vessels today, with the introduction over time of more biomethanol and e-methanol as we facilitate the transition to low carbon and net carbon neutral methanol, with more ships using methanol as the fuel and the market expands. Our joint report with ARENA also provided intricate assessments of the cost of renewable methanol production today and where it's heading in the future. Current spot market pricing in the U.S. Gulf Coast is $380 per metric ton, or the high end of the light gray bar shown on the bottom here. Depending on feedstock costs, some biomass and biogas processes are economically competitive today, with conventional methanol as shown in the green bars. Where we can expect to see dramatic cost reduction in line with expectations for more affordable green hydrogen is in future production costs for e-methanol, pictured here in the blue bars. All alternative fuels will be more expensive to produce than conventional fuels. That's just a fact. How much more expensive depends on the availability and cost of renewable power or biogenic feedstocks and the proximity to major alternative fuel hubs. Based on our experience with both e-methanol and biomethanol production, we can readily predict costs will fall with scale and improved efficiencies to become competitive with conventional fuels. Methanol does have half the energy content of diesel bunker fuel, so you need nearly twice as much methanol to provide the same range as diesel fuels. But even on an energy adjusted basis, we've seen that methanol has been price competitive with traditional diesel bunker fuels. Today, there's a call by many, including the world's largest shippers, for a carbon tax on diesel fuels. Clearly, a tax on diesel bunkers would dramatically change this pricing picture for marine fuels. with the only available options today besides diesel fuels being advanced biofuels, LNG, and methanol. When we look at fuels for the transport sector, energy density matters. Again, while methanol is just half the energy content of diesel bunker fuels, it's a liquid at ambient temperature and pressure with a higher energy density than other alternative fuels like ammonia, hydrogen, or batteries. From the perspective of energy density, logistics, and fuel storage, methanol is a much more efficient energy carrier. If we think of the global resources for solar and wind power, it'll be much easier and cheaper to turn these green electrons into liquid methanol and move it around the world. Today, around the world, methanol is being used as a fuel for cars, trucks, ships, industrial boilers, cook stoves, kilns, home heating, and as a hydrogen carrier for fuel cells. As we look ahead to potential markets for road transport, and particularly in shipping, methanol demand could greatly exceed the growth that we've seen to date. And of course, there are now a number of leading shippers such as Maersk, which are not only considering methanol as marine fuel, but have already adopted it or are announcing plans to include methanol within their fuel pool. These first movers understand that little time is left to wait on potential solutions which might fulfill 100% of the 2050 goals. We don't have 30 years to wait. Maersk announced in March that their first carbon neutral vessel would launch in 2023 running on methanol, a full 7 years ahead of schedule. Recent press stories note that Maersk is now looking to place a $2 billion order for 12 15,000 TEU container ships running on methanol. And I'm sure this makes Kjeld very happy. And Maersk sees methanol as a viable option for both new builds and retrofit vessels. There are vessels on the water today using methanol, dual fuel engines, including a dozen 50,000 deadweight ton chemical tankers with manned two-stroke engines. One of the world's largest RoPax ferries has been operating on methanol for 6 years now, using Wärtsilä four-stroke engines. We've run a pilot boat in Sweden and a dry bulk barge in China on methanol. And there are also vessels that use methanol as a hydrogen carrier for the hotel load or for propulsion. These ships have allowed more than 100,000 hours of operation on methanol so far. More methanol-fueled ships are on the way. As you can see from these recent announcements, the vessels being built now include more chemical tankers, tugboats, workboats, yachts, and cruise ships. Methanol can be an attractive option for ocean-going vessels, short-sea shipping, workboats, port and inland waterway type vessels, and fishing fleets. Global methanol producers like Methanex and Promon have invested in methanol-fueled vessels, showing industry support as first movers. And we'll hear from Promon shortly. Last fall, the IMO adopted safe handling guidelines for the use of methanol on board vessels under the IGF code for low flashpoint fuels. This has been an important milestone in the growth of methanol as a marine fuel. As you can see here, this process took a number of years. And while LNG paved the way for methanol, methanol's adoption can be a model for ammonia and hydrogen in the future. Let me quickly mention two projects that we're involved in Europe. First is the Green Maritime Methanol Program in the Netherlands. This is moving to the next stage, GMM 2.0, with the adoption of methanol for short sea shipping in the Netherlands. The Fast Water project, also in Europe, is looking at workboats and river cruisers with a pilot boat launching in Sweden this fall and 2 tugboats launching in the port of Antwerp early next year. Now, methanol is one of the world's most widely shipped chemical commodities. Again, we produce 100 million metric tons. About half of that will move from one continent to another. Methanol storage is already available at more than 100 of the world's largest ports. Last year, we worked with Lloyd's Register on developing bunker guidelines for methanol and also supported work by the EU SIN to develop bunker guidelines for methanol's use in Arctic shipping. The pictures here show truck-to-ship bunkering of the Stena Germanica RoPax ferry in Gothenburg. In May, the first bunker barging of methanol took place at the port of Rotterdam, transferring a 300-ton stem from a barge to one of the methanol dual-fuel chemical tankers. Again, as a liquid at ambient pressure and temperature, the handling of methanol is very similar to that of diesel bunker fuels, making methanol an affordable option for bunkering. Methanol is also a more environmentally benign fuel than diesel bunkers. Nearly 200 times more methanol is needed to kill half the population of fish in a water body compared to diesel fuel. Now, I like to say that if the Exxon Valdez had been filled with methanol instead of oil, you could have gone back to that site 2 days later and not found a trace of methanol. And with that, this is our contact information for our global team, and where I'm based: Washington, Singapore, Brussels, Beijing, and Delhi. Please check out our website at methanol.org, and you can follow us on social media. And with that, I'll thank you, and we'll hand back controls, and we'll turn to our first presenter from the engine perspective, and that would be Kjeld. Kjeld, you're up.
Thank you very much, Greg. And you can hear me now?
Yes.
Just want to go up here. Yes, and you see my screen? You see my screen now?
Yes, we can.
Okay.
Yep, you're good.
Okay. Thank you, and hello here from Copenhagen, and thank you very much, Greg. I will talk about the MAN B&W LTIM engine. It's liquid gas injection methanol engines. We have a number of dual fuel engines today, and except for one, which is a MEGA engine, which is an Otto cycle based engine, they all are diesel-based engines. That means the diesel principle, both for here methane, ethane, methanol, LPG, and also coming up for the new ammonia engine. We have an expectation that there will be several different fuels in the future. And as technology providers, we just, you can say, listen to the market and see what is the requirement. And based on that, we make priorities in our development and planning. The history here for the first methanol engine was that we decided we could see the market, the need from the market. We made demonstrations here in Copenhagen on our test engine number 1. Then we had tests at Mitsui, one of our big licenses, and another big licenses at Hyundai. And then the first sea trial on methanol was here in 2016. So it's quite a number of years where we have actually been operating on methanol. The methanol itself, as Greg also specified, there is specific energy compared to other liquids. That's about maybe around twice the amount is needed for giving the same output as MGO. But the efficiency of the engines and the power output and everything is exactly the same when we base it, as we have done here, on the diesel principle. We will not have any, you can say, we will not be sensitive to the quality of the fuel itself and the ambient conditions and so forth. The operator will really not feel if he's operating on methanol or he is operating in diesel fuel modes. Also mentioned by Greg, we have the methanol in normal atmospheric pressure. We will have a supply system which we will come a little bit back to, but it's quite simple. 8 to 10 bar is the same we use also for MGO, and we have a booster system which pressurized the methanol up to 600 bar when it's injected into the combustion chamber. And SOx, NOx, and particulates have quite an reduction, and also 10+% reduction in CO2 when we compare to what we have seen on our heavy fuel oil burning engines. Today we have the G50 and S50, and 50 is the bore size in centimeter. You see our engine program go from 3 megawatt up to 83 megawatt in different engine sizes. So not all of the engine in the engine program is actually ready now for burn methanol. But again, coming back to the request from the market, there will be much more of different engines that can burn methanol in the future. At least this is our expectation. This is our reference list today, and we have totally 23 engines ordered for methanol operation. This 2,200 TEU feeder container vessels for AP Møller, as Greg also mentioned, is not included in that, but will be, of course. And without going in more detail, I would say we expect really a lot of more orders from methanol engines shortly, you could say, in due very short time. The complexity in the installation, the price is also very important when you compare the different dual fuels. And we have, together with Methanol Institute and DNV and Hyundai, we have made a study to see what is really the price difference. It is just a cargo, a tanker, which about 54,000 cubic meter. If you say the capex here is 100%, then it would be 110 for the methanol burning engine and vessel, you could say, but it will be 122 if it's LNG here. So there is actually quite an increase in capex when you use the LNG instead of the methanol, and it will still be the same efficiency you will get out of the two vessels. Here is the world's first barge-to-ship bunkering of methanol. Of course, that will be much more needed when it will be non-methanol carriers that now is going to burn methanol on board. It is, in the diesel principle, quite simple, you could say, because what we do is we add on an extra injection system. We need some hydraulic oil, and that is 300 bar. It is to activate the booster pump, the fuel booster injection valve we have here, which boosts up the pressure to 600 bar before it's injected into the combustion chamber. We have the double wall piping here. It is a concept we use for all the dual fuel engines, where we have sniffers and alarms sensors sitting in between the two walls, and if anything, if any leakage is measured, then momentaneously the engine will change to fuel oil mode and go away from the utilizer of methanol, and we will purge the lines and so on. So there is a lot of safety built into the system. Methanol is not really a good lubricator, so we also use sealing oil where we have lubricating the moving parts and so on. So all this is, of course, considered in our design and so on. Here we have a sequence of pictures for different fuels: gas oil, methanol, methane, ethane, and LPG. And you will see here in this sequence how you can say the burning actually shows, but also the real ignition. From this movie sequence, one can clearly see that all the fuel burns in the classical diesel process, and that the level of soot radiation vary significantly. And if you see here in the late one, here with methanol emitting very low level of visual radiation, and that's of course also an advantage. We go into hazard investigations for all the dual fuels, new fuels, low flashpoint fuels, which is introduced to our engines, and we do a lot of them together with classification societies, yards, engine builders, and of course also operators and ship owners. We have a fuel gas supply system, and as mentioned before, 8 to 10 bar before going into the engine, very similar to a normal fuel oil burning system. We have a low pressure pump from the tank. After the tank, we have a high pressure pump for the circulating system and so forth. And it really works and is quite simple. Also, you can say shown or reflected in the CapEx difference between the LNG cryogenic types systems and here the liquid systems. We have normally in the diesel process where we have this very high efficiency, we also have a high peak temperature and combustion chamber actually creating a lot of NOx. Now the NOx level for methanol is relatively low, 30 to 50% lower than it is for fuel oil. So you can say you have a good start, but on top of that, we are actually able to put water in and mix it with the methanol and reduce the peak temperature and also therefore then the NOx formation. Otherwise, in the other dual fuels, you need to use an SCR or an EGR solution in order to be in compliance with Tier 3. Here we see what actually happens. In the diesel dual fuel engine, you inject the pilot oil ignites, and then you inject, in this case, methanol directly into the burning flame, also giving you a very good control of the burning process, and thereby also keeping the high efficiency and low emission. This is how we blend water in, and the last many engines sold is actually sold with this system where we put water into the line here and mix it very easily, you could say, in a mill into the methanol before it goes into the engine and thereby reducing the NOx level. Here is a little bit about, you can say, the amounts we are talking about with methanol and water. We have the water content up here, we have methanol here, and here is water to methanol content actually shown here. So there is much more methanol still compared to the water injected. This I will not go in detail with. Greg have already shown that, and as Greg said, we will be happy about this, and for sure we are very happy and speak a lot with Maersk about it also in these projects, that's for sure. We have a methanol paper, if you like, and there is contacts here where you can see. The diesel principle also have this, or you can say the beauty of the diesel principle, but basing that on the dual fuel engine, is that you can go from an MEC, that's a full electronic control engine, and you can retrofit for LNG, LEG, methanol, LPG, and coming for ammonia. And we have already made some of these retrofittings. We have retrofitted one of the MEC engine to ethane, 3 to LNG, and 7 or 8 now for LPG, and 7 or 8 is still waiting in process on an order. And there will be much more in the future. And if the CO2 taxes is hitting on and so forth, then suddenly will be a bigger business case to go for those alternative fuels. So thank you very much. That was presentation from me.
Great, thank you, Kjeld. And let me remind attendees that you can pose questions in the chat functions, and we'll get to those in the panel discussion after the next two presentations. And with that, we're now up to Tony. Tony, the floor is yours.
Thanks, Greg.
Yep.
Let me see if I can manage the computer sharing as well. Works sometimes, not always.
Right.
So, okay. Let me know.
There you go. You're good.
Okay.
Yep.
Are you seeing the presentation mode or?
Yep. Yeah, we're seeing the slide mode. That looks good.
Okay, good.
Yep.
So maybe just come back to why is this important? What's going on out there, and why do we talk about methanol? You all recently have heard about the efficiency index of existing ships, EEXI. We have the carbon intensity index. We have the Europe trade system for the carbon, which is introduced now for this Fit for 55. And there is a lot of other schemes and initiatives going on about the carbon tax for maritime industry. And we need also to understand that the ships that are built today, they will be in operation in 2050. Typical life cycle of a ship is 30 plus years. So if we are going to be in compliance in 2050 with a 50% reduction in greenhouse gas emissions, we need to prepare and start executing today. And it's not a question anymore of when. It's more a question of how. And methanol is one of the solutions that could put the answer to the how question. And this is what we'll be exploring today. From Wärtsilä point of view, we have been working on alternative fuels since a long time ago. Already in 2000, we introduced the methane, and we have a methane operating engine in 2003. We have introduced methanol in 2013 and converted Stena Germanica in 2015. We are currently testing ammonia, and we'll have an engine operating next year on ammonia. And we expect to have a pure hydrogen engine operating in 2025. So we are doing what the market is expecting from us and providing the solutions for the future. If we look into the flexibility of the engine, there are a couple of combustion types that we use in our engine. There is the diesel, the DF, the SG, which is spark ignited, the gas diesel, and the liquid gas. And all of these combustion technologies can be used with various fuels, and we can see that methanol can be applied as an alternative fuel to most of these engine combustion technologies out there. But of course, industrialization will be needed for this in order to adapt the methanol for these engines. We have the technology, we have the knowledge and experience, and we are ready to continue the development in order to meet the demand from maritime industry. We have invested around 50,000 engineering development hours in a methanol technology. First concept study was done back in 2011, where we started to look into alternative fuels and identified methanol as one of the best options and alternatives compared to HFO. And back then, this was driven by the SECA legislation and SOx. Now we are moving into the decarbonization, but the availability and an option for methanol is still there. So since 2013, we have been continuously investing development hours, and we have 6 years of continuous operation on Stena Germanica since the conversion. So there is a great accumulated knowledge that we can apply to the solutions in the future. Now, maybe not repeating from what was said by Kjeld and you, Greg, and I think both of you made quite some good points. I will try not to say same things again. But when choosing combustion technology for methanol, we were starting from the phase of the methanol, and methanol is a liquid. It's an alcohol. So compared to all the other alternative fuels, it's a liquid at atmospheric pressure and temperature. So as such, injecting in a port injection, as normally you would do with gas, would mean that the methanol will be in touch with the port inlet and with the combustion chamber. And we all know that methanol is highly corrosive, and as such might affect the lifetime of the engine. And maybe for automotive industry, this is not an issue, but an engine have a lifetime of over 2,000 hours. Our engines have a lifetime of 200,000 hours and more. And when we design engine and deliver an engine, we will support the engine throughout the life cycle of 30 years and extensive running hours. So for this, we need to have methanol to be proven in a daily operation and continuous operation, and not just do something in the lab. So this is why we chose, quite similarly to MAN, to inject the methanol in a high pressure diesel combustion cycle, because if we would choose to inject it in a port inlet, we would need to heat it up to around 125 degrees, and that's just at a 10 bar pressure. And as you go higher with the pressure, you need higher temperature in order to get the methanol in gaseous mode. The technology layout that we have chosen originally was adapted from the gas diesel engine, and then it was further developed for a conversion to Stena Germanica. So we started from an existing technology and then did the tweaks in order to accommodate methanol. So the main development is around the injector, and the injector in this case is dual fuel injector that can accommodate both fuels simultaneously in the same body. So we use one injector for both fuels, and this injector is designed to have 100% output on both of the fuels, either methanol or diesel. The control of the injector or the injection for methanol is done by hydraulic oil and a solenoid valve, and this is electronically controlled opening and closing of the injection of the methanol. The methanol is injected at a high pressure in a common rail system, which is pumped by a single pump before the engine, and the pressures are similar to what we saw before, around 600 bars of pressure that we use in a common rail. We also use the standard diesel jerk pump for both pilot fuel injection and a full diesel output operation. So the same pump is used. Switching between fuels is simultaneously and seamless as well. You will not notice any change in operation mode or drop in load or efficiency. So the fuel switching is seamless, and it can happen at all loads back and forth. We also have a nitrogen generator in the system, which is mainly used for blanketing of the methanol storage tank, but we also use it in order to purge and drain the methanol lines before we do service or maintenance. In normal operation, we don't empty the methanol line. We use sealing oil to seal the methanol inside the injector, but also to lubricate the needles of the injector, because the methanol is very dry, and we need some oil to have the needles operation swiftly. How this works is that when the piston is close to top dead center, we press the cam, by the cam we press the diesel jerk pump, and the diesel jerk pump injects a small amount of pilot fuel in this yellow line, and that is then ignited by compression and temperature. And at that moment, when there is ignition flame in the combustion chamber, we start injecting the methanol on top of that flame, which is directly ignited and combusted, pushing the piston down. So the methanol burns at the flame, and it burns completely without getting in contact with any parts in the combustion chamber. The performance of the methanol, we see that, or methanol combustion, we see that the NOx levels are lowered by 60% in our case. So we are not as near to tier 3, but quite close. And we have also done tests with water blending and see that we can reach the tier 3 compliance. When we talk about retrofit conversion, it's important to notice that converting to methanol as fuel is not seen as major conversion by the classification societies. And as such, it will not require the new tier compliance. We can just prove that we have lower NOx emissions and we don't need to recertify the existing tier compliance, but can keep it as is. And for retrofit, we are not compiled to meet the tier 3, maybe only in certain cases where the local legislation require that, and that can be achieved by water blending. We see that combusting methanol creates zero particulates, and that of course affects the smoke emissions. So the only smoke which is emitted comes from combustion of the pilot fuel, and it's barely visible, maybe on a very low loads where there is more pilot fuel ratio compared to methanol, but on higher loads there is no visible smoke with methanol. And the temperature on the engine is also lower, which means that there is a lower thermal load on the engine, and we can expect a longer lifetime of the engine and its components. We have also observed better fuel oil consumption, and this needs to be reconfirmed for other different engine types and installations. But since methanol burns very rapidly and releases its energy very fast, we have observed increase in efficiency of the engine. As mentioned, there is a CO2 reduction which comes from lesser carbon content in the fuel. So there is a lesser carbon to hydrogen ratio in the fuel, and depends on what you compare to. But if you compare to MGO, the difference is 7 to 8%. If you compare to HFO, the difference is higher than that. How does this look on converted chip? These are pictures from Stena Germanica. We can see on the first picture the engine before conversion with the standard diesel lines or heavy fuel lines, and then on the right picture we see the same engine which is then converted to methanol with the new cylinder heads and new injectors, and of course a lot more piping that control the sealing and control oil and methanol return and nitrogen for purging. So there is an addition of new piping system, and we do change the cylinder head because we have a bigger injector, but none of the engine parts below the cylinder head are changed. So the engine remains intact when it comes to piston rings, liners, and all the parts in the below part of the engine. Of course, there is a lot of cabling and a lot of automation and safety systems. This is quite an installation. It's specific, depends on what is your starting point and how old is the engine. This ship was originally commissioned in 2001, and it was already 14 years old when we retrofitted it to methanol. And it's now 6 years in operation with these 4 converted engines in methanol. You can use existing, let's say, void spaces or ballast tanks or existing fuel tanks, which can be painted with a zinc silicate and repurposed for methanol. And we also have, in this case, a pump room, but these pumps are actually approved for engine room installation and can be installed in an engine room if there is enough space for them. So depending on installation, the retrofit can be done in many various ways, but the couple of feasibility studies that we have done have all showed that the conversion is fully feasible for all the installations that we have looked into. We do have a plan for releasing another engine type based on the 32 bore. And this is a development which is planned currently, and it's proven technology. The Wärtsilä 32 engine is already on the market, and we have around 4,000 engines delivered since the conception of the 32. And it's still a portfolio engine that we deliver today and will be delivering in the future. It's in the power ranges from 3 megawatt to 9 megawatt, and fits a lot of installations, both as a main engine or as an auxiliary genset. And this engine will be based on similar technology to what I just showed, and could be delivered both as retrofit of the existing 32s or as a new 32 engine from late 2023. Looking into the future, I think, as you said, Greg, and not repeat, but renewable fuels are the path for the future, and the methanol as a transition to this is an excellent starting point, as we saw from Greg's presentation, that it can be produced from a variety of feedstocks, and the main benefit is that it's liquid at atmospheric temperature. It does not require cryogenic storage. It can easily be transported through various supply chains and bunkered on board. So we do see that going forward, that the bio and methanol as a hydrogen carrier would be a great essential fuel for the path to decarbonizing the shipping industry. With that being said, the last slide from myself and from Wärtsilä is that we do, looking into the future, we will have multi-fuel engines that will have a different fuel injection system and will be capable of burning various fuels like hydrogen, ammonia, methanol, and other possible carbon neutral fuels. And this is the path that we will continue exploring and developing our engines. Thank you. Over to you.
Great. Thank you, Tony. I see that we're getting a number of questions in the chat, so a couple of specific questions that'll come back to Kjeld and Tony during the Q&A panel discussion. But our next speaker is Anita Gadjadar. So Anita, the floor is yours.
Okay. Hi, good afternoon, everyone. Hopefully the technology doesn't fail me, so let me just try to share my screen. And hopefully, Greg, you see it in presentation mode.
Well, let's get your notes too, but
no,
it's the 2 slides.
That's odd, because I see it's in presentation mode.
That's better. I did it.
Oh, and did it change now? Okay.
Yes.
Okay, try it again. All right.
That's good.
All right. Good.
Thanks.
All right. So good afternoon, everyone. You know, the technology is something that sometimes fails with all these webinars that we're doing. It's definitely been different. So as Greg mentioned, I'm here to offer the view and our perspective as a producer, and you know how we view methanol as a future fuel in the market. Let me start by just giving some background on our company. Proman, we're a global leader in petrochemicals with methanol, ammonia, and urea ammonium nitrate assets globally. As some of you may know, we're actually the second largest producer of methanol in the world, and we have our production assets in Trinidad, in Texas. We always boast that we have the largest methanol plant in the world. Well, at least we used to, which is in Trinidad, the M5000 plant, and the smallest methanol plant possibly in the world too, which is in Pampa, Texas. We have also a plant in Beaumont, Texas, where we have a joint venture with OCI, and we have a methanol plant in Oman, which is the OMC plant. We because we're also involved in ammonia, we have our joint venture with Coke for ammonia plants in Trinidad. At Methanol, at Proman, we're involved in the entire supply chain and value chain, specifically of methanol. We're involved in the construction and the design of the plants. We're involved in natural gas production in Trinidad. We're involved in the petrochemical production and the supply, marketing, and logistics of the product to our customers. We ship product to over 50 ports and have storage in over 25 locations globally. So many of the presenters before have spoken about the challenges that we face in the international maritime sector, but one of the major challenges that we will face in the upcoming years, of course, is the IMO reduction rules on carbon intensity, and the fact that by 2030 we have to shift to at least reduction of carbon emissions by at least 40%, and by 2050 carbon intensity requests to reduce to about 70%. And now that's the IMO, and it's been debated because a lot of the global leaders have even stricter regulations. And of course, last week the EU came out with their Fit for 55 obligation, where they'll actually like to reduce emissions by 55% by 2030 in the EU, and become carbon neutral by 2050, which is different from the IMO's targets, and it's something the shipping industry will have to work together to try to meet. We also have heard the US speak about their carbon neutral targets as well by 2050, and Great Britain has pledged to reduce their CO2 emissions by 78% by 2035. Even China is saying that they would like to be carbon neutral by 2060, I believe. So we're seeing this transition in the shipping industry, and as one of the previous presenters noted, when you build a vessel today, you tend to build a vessel for 15 to 20 years, and if we were to do the math, it means that a vessel that is built in 2025 would still be around in 2040. So we need to try to meet that 2030 target, and for us, we feel that methanol, it's proven, and we viewed it as option in trying to meet these carbon reductions. Shipping, as many of you all will know, is responsible for 3% of the global carbon emissions globally. And it might sound very small, but if you look at the industry as a whole and the targets that we have to meet, it will require a significant amount of fuel, not just methanol, but other alternative fuels, which we've been hearing more and more about in recent times. So why methanol? Well, I don't want to go in a lot of details because Greg would have also mentioned a lot of these things, but it is a clean burning fuel. We also view it as cost competitive. When you look at the long-term pricing, which I will speak about later in my presentation, it is competitive to when compared to alternatives. In terms of bunkering, it is easy to bunker, it is safe to bunker, it is available in more than 122 ports, as presentations previously would have shown as well. The capex for the modification of vessels is a lot cheaper than LNG, so you don't have to put out as much in your capex, and it is fully biodegradable, and this, I think, it's one of its strongest points as well. I will not go into too much details here because, of course, Greg gave a very good explanation on gray methanol, blue methanol, and green methanol, and the fact that methanol, if produced as a green molecule, a blue molecule, or a gray molecule, it's the same molecule, it's the same characteristics. And this is important because, of course, now there's a lot of talk about carbon trading, and there's that question of how do you move green methanol or green products, I should say, or carbon low carbon emission products, how would you move it to ensure that you also reduce the carbon footprint in that transportation? The good thing is that if methanol is produced as in its green form in, let's say in Canada, and we produce gray methanol in Trinidad, maybe we could work together with partners to swap around product, because to benefit from that lower carbon footprint and not have to incur additional emissions to transport that, for example, to Europe. Again, here, I probably wouldn't get into too much details because it was mentioned, but methanol is easy to bunker. The capital infrastructure required to transform a bunker barge into a methanol bunkering barge is very low. Methanex was very successful in bunkering methanol in Rotterdam in early May. And of course, at Proman, we would also like to engage in projects like this. And we continue to have discussions with bunker suppliers, etc., so that we can set up a similar demonstration, probably in a different port, to show how easy methanol is to bunker when you compare it to LNG, for example. As I mentioned, we view methanol as competitive. Yes, it requires twice as much when compared to marine gas oil. But if you were to look historically of the trend between marine gas oil prices and methanol prices, you would see that over the period of the last 10 years, methanol in most instances, and we looked at Rotterdam as our example, traded below marine gas oil. And, yes, there are times like any other commodity where the market is one where the price of the product is trading high, but it's not something that is always sustainable. And that's why we think methanol in its current form is a good alternative to marine gas oil and could provide a very good solution when it comes to costs, especially when we compare it to LNG. In terms of scalability, and again, most people spoke about Maersk already, but one of the 2,100 TEU vessel that Maersk announced, that will require about 25,000 metric tons of methanol per year. In fact, if they were to go forward with the 15,000 TEU, that might require as much as 70,000 tons of methanol per year. And one of the challenges we always hear in the industry is, well, there's not significant capacity. How do we build capacity for methanol? Well, let's put it in perspective. If we average it out, one vessel requires 20,000 tons of methanol. 100 vessels will require 2 million tons of methanol, and we should note that the global vessel fleet is about 56,000 vessels. So we don't need a lot of vessels to convert to get 100 vessels, which would require 2 million tons of methanol. And right there, we have the need for one new methanol plant. So it takes about 3 years to develop a methanol plant. So that concern about, well, will the methanol tons be available? We know it can't be made available. And, they always talk about the chicken and egg situation. Once there is a demand for methanol, we as producers will build plants to meet that demand. And we've seen it over the last 6 years in particular, where we've seen a huge demand for methanol from the MTO sector, and there's been increased capacity to meet that demand over the last 5 years. As Tony mentioned, methanol is it's rich in hydrogen, and it has an important role, we view, in decarbonization. It's easy to manage, inexpensive to store and transport, and we view it as having a low carbon pathway when derived from natural gas, either in its traditional gray form or when combined with carbon capturing as a blue methanol. Green methanol, as you all know, is also gaining a lot of momentum, especially since Maersk has indicated that their intent is to use green methanol by either bio or e-methanol. And green methanol can be produced 2 ways. As I mentioned, e-methanol, which is derived using hydrogen from renewable electricity and CO2, or as biomethanol when produced from sustainable biomass. as the world shifts really to this green future, with major regions like the United States and EU trying to meet their targets, Proman is actively leveraging our operational expertise and deep industrial knowledge to capitalize on the transition to a greener economy via our investments in and strategic partnerships with external stakeholders and the promotion of methanol as a cleaner fuel. Our plants in Trinidad and Point Lisa's actually already utilize CO2 from our ammonia assets. So one can argue whether we already produce blue methanol because we're capturing the CO from the ammonia plants. And Greg
Uh-oh. Looks like we lost Anita. We'll give her a moment to try to reconnect. And I do see that we're getting questions in the chat, so we'll get to the Q&A in just a moment. Hopefully we can get Anita back shortly.
Hi, Greg. I think we should go to a few questions whilst Anita sorts out her technology.
Okay, yep, we can do that. And maybe I'll take the moderator's prerogative and ask the first question. As we talked, the Stena Germanica launched in April 2015 using Wärtsilä methanol dual fuel engines. A year later, in April of 2016, Waterfront Shipping, Marinvest, Westfall Larsen, MOL launched 3 methanol dual fuel chemical tankers. And for both Tony and Kjeld, as engine OEMs, I know you're both doing testing programs on ammonia and hydrogen. How would you assess the technology readiness level of methanol today compared to ammonia and hydrogen? And similarly, what were some of the challenges that you were able to overcome on methanol, and how might those compare with the challenges in your current work with ammonia and hydrogen? And either Kjeld or Tony, whoever wants to go first.
Okay, I don't know, Tony, will you or should I?
Yeah, please go ahead, Adolf.
Okay. Challenges, yeah, I spoke about the hazard investigation, and that's something that is, of course, extremely important when it comes to safety and safeguard. And you can say build in safety several times. If you typically see the first LNG engine we had, it had a lot of safety that we have now been able to minimize to a more natural level. So you can say we have also for ammonia now made hazards. We have made 3 or going to make number 4 now, and there has not been any bottlenecks when it comes to the safety part and the design of the fuel gas supply system. It's much easier, I would say, on the engine side itself. It's very compact. The ammonia as the methanol will go through a distribution block from the double wall piping and into the cylinder cover. So there will not be any open lines, you can say, where things can be dropped on and damage, and then you have leakage. So I have to say hydrogen, we have not from two-stroke looked at hydrogen yet, because the market calls for ammonia as the next not the next, but another alternative dual fuel, not hydrogen when it comes to ocean-going vessels. But we see still, as also mentioned in the presentation, methanol is very, very simple when it comes to the fuel gas supply system and to ensure that all the safety is followed. That means also it's easier for the persons on board to actually handle the methanol. But on ammonia, we don't see anything that any showstoppers when it comes to the design and development, not for the fuel gas supply system and not on the engine itself.
Thanks, Kjeld. Tony?
Yes, if I amend to these comments, The technology readiness is, of course, a shorter path to methanol than to ammonia or hydrogen, as mentioned, because we have been using methanol in the past, and then methanol have been developed on an existing technology platform. However, I mean, we can use many different combustion technologies and concepts, and when we start to develop the next platform, we will be developing a platform that can accommodate all of these fuels which are on the market. So the ideal would be to have one platform that can be easily tweaked to burn both natural gas, methanol, ammonia, and then have a MGO as a backup. So why we are developing a hydrogen engine is mainly because we supply engines to the power plant market as well. And it's the same engine technology, and this is where the biggest demand comes from. I do see a big challenge with liquid hydrogen and shipping industry, because it's going to be a challenge to have logistic chain around that.
And Tony, with your W32 engines, you mentioned that there are 4,000 in the fleet already. Is that a mix of marine and stationary power?
That's a mix of both marine and stationary. Yeah. So maybe 60% are marine and 40% are stationary.
Okay, great. Yeah, Kel, you talked about water injections to reduce NOx, and Tony also mentioned water injection, but is there any risk of harm to the engines or concern about putting water in?
No, actually not. It's you know, it's like a gin and tonic. Some are saying that you put it together and you have one fluid, homogeneous fluid. It will not harm the engine. It will be, you know, already we have the lubrication with the sealing oil when you inject. That's the injection part of it. And then you have in the combustion chamber, you will not have any of the liquid reaching and touching the cylinder walls. And we have shown also by testing that it's no harm on the oil film, because that would really be the critical one, but we don't see that at all. It's not reaching the liner walls as water as such.
If I just add briefly to what Kjell said, pure methanol can be carried in a black steel pipes. So, but if you blend methanol and water, you will need to go to stainless. So it's important to know before if you will be using water blend or not. But it's a minor difference. The combustion temperature, the adiabatic flame temperature, when combustion happens in the cylinder liner or in the combustion chamber, it's very high, and this will evaporate any water without, as Kjell said, touching any of the other components. So yes, no.
Okay, great.
Anita's back.
I see Anita's back.
Like I said, when the network in the office goes down, you also lose your connection. So
Right.
apologies.
Did you have a couple of slides that you wanted to finish, or was that the bulk of your discussion?
No, I think I have no idea where I lost you all, because I apparently kept on speaking and then realized that there was nothing else. But I was almost finished. I think I just had about 2 more slides or 3 more slides to go through, just to mention our project and that we're invested in a biomethanol plant. And I know the audience will get copies of the slides, so I guess that will work.
Do you want to just quickly mention the work that you're doing with Stena Bulk and the vessels that you've placed an order for now?
Exactly. So we have 6 vessels that Proman has ordered, dual fuel vessels with MAN engines. 3 of those vessels are jointly owned between ourselves and Stena Bulk, and the other 3 are 100% owned by Proman. These vessels will be delivered over the period 2022 to 2023. And while 4 of the vessels at least will be used within our fleet, we hope to trade the other 2 in the international market because, you know, as everyone knows right now, methanol vessels, or actually the only company that has been using a methanol tanker is Methanex. So we also wanted to show other ship owners that methanol dual fuel vessels, tankers, can be used to move any product, not just methanol. So our intent is to trade these vessels globally as well and move different products beyond methanol.
And Promon is also now looking at moving beyond the conventional natural gas-based methanol production. And you've got a project with Enerchem in Canada for waste to methanol.
Correct. Yes, so that I think that was the slide I was going on to when I got disconnected. So we have a project in Quebec with Enerchem, and that project will be using biomass to convert it into biomethanol. We will be producing around 100,000 tons of bio and circular methanol, and our intent, of course, is to export this and to use it hopefully in the marine fuel pool. You know, I think it's sometimes also important to note that we at Promon, we view gray methanol right now too as a transition fuel, as a pathway fuel, because in reality, gray methanol does have its benefits and it does reduce carbon emissions by as much as 10 to 15%. And it also eliminates particulate matter, which is a significant achievement for a fuel. So we will be using grey methanol on our vessels when they're delivered next year. And hopefully once we have the biomethanol, which we hope to have on the market, the plant should be completed in early 2024, and we'll be able to have that biomethanol available on the market.
And Anita, you talked a bit about methanol pricing, but have you looked at how methanol pricing compares with some of the other alternative fuels like biofuels, hydrogen, or LNG? And is it not just a fuel, but like a total cost of ownership as well?
Yeah, I mean, we looked at so we've looked at it on both ways. So we've looked at gray methanol and we've compared it to marine gas oil. And as I hope I have no idea if that slide showed as well, but it is competitive. When you look at green methanol, I mean, everyone always speaks about how costly green fuel is, and it is a fact, it is more expensive. But we recently were doing some research on biofuels because a few shipping companies are blending biofuels into their existing pool. And biofuels is actually around $1,200 per ton and upwards for biofuels. So when you do the comparison, methanol, green methanol, is actually going to be a little bit cheaper than some of the biofuels that are available in the market today. As an ammonia producer too, as well, I could mention this. And the fact is, ammonia and methanol prices tend to trend along the same lines, and ammonia prices historically too have gotten very high. And if you were to plot it, methanol and ammonia will be competitive compared to each other. So that's also something that we need to note.
We also have a question in the chat that's looking at, so the methanol market is currently 100 million metric tons, but if you look at the diesel bunker market, if we were to displace a significant share of diesel fuels for shipping, we would need to ramp up methanol supply pretty dramatically. I mean, you showed 100 vessels could use 2 million tons, or the output of one world-class methanol plant. The report that we did, the Methanol Institute did jointly with ARENA, showed that methanol demand globally, according to ARENA, could go from 100 million metric tons to 500 million metric tons by 2050. And you know, we've certainly seen over just the last decade that methanol demand more than doubled. Maersk, I know, has talked about being confident that their first feeder vessel will be able to operate on carbon neutral methanol. Anita, are you also confident that the industry can grow to meet the demand for shipping? And also, how do you see the role of conventional natural gas-based methanol facilitating that transition to green over time?
Exactly. So I think in today's market, and as I just mentioned, actually, that gray methanol, it already reduces carbon. And I think there is a role for gray methanol as a pathway fuel as we move towards green. Green methanol projects thus far, it's small scale projects, but that's because, of course, and that is what impacts the production cost. But in reality, and we've seen it in the methanol, the gray methanol world as well, if we look at a plant that was built 20 years ago, it was a lot smaller than a plant that's built today. And you achieve economies of scale as you grow and build bigger plants and improve efficiencies. And I expect to see the same thing for the biomethanol and e-methanol plants over the next 30 years. I think for the gray methanol, there's a market that is readily available, and we can do that today. If in terms of building vessels over 2025 to 2030, a methanol plant takes about 3 years to build. So once we see that demand, as a vessel takes about 2 years to build and a methanol plant 3 years. So in reality, we can meet the demand that is required at least over the next 10 years for gray methanol as we transition into green.
Great. Thanks, Nita. Kjell, you talked about the methanol engine showing CO2 reductions of 10%. I think, Tony, your number was 7 to 8%. There's a question here. If we look at the well-to-wheel emissions for gray methanol, how does that compare with natural gas LNG engines?
Yeah, it's, oh, sorry. Yeah, can you hear me now?
Yes.
Yes, okay. If I start, first of all, I think Tony, you talked about 7 to 8 if it was distillate, and heavy fuel oil it would 10 and maybe more. And Nita said up to 15%. We have also seen in single cases up to 15%. So what we have done is we have referred to what IMO is actually utilizing in their calculations of the EEDI and so on, just to have a reference, an official reference. Yeah, it is all about well to wake. So we cannot tell it. We cannot say what is the total footprint, and what is missing still is some way of international regulation saying that worldwide, considering whatever is necessary, then you have possibility to compare the well to wake. If you look at the different study which is made by different, you could say, third parties, but also interest groups within LNG or what it could be, then you can see that they do not agree what the footprint is for LNG, for instance, when it comes to well to wake. And we need that comparison in some way in order to understand what should be the future fuel and what should such a carbon tax be based on.
If I add on this, I think it really depends on who you ask. We have all read the various research papers, and the numbers are actually so distant from each other, so you cannot actually say it's this or that. If you have a natural gas production close by your operation, I would say the natural gas carbon intensity would be lower. But if you need to transport the natural gas from Louisiana to Europe, then and compare that to methanol, then methanol would be, of course, much better. So a unified index measurement for this would be needed, but I don't think that the industry will agree, honestly, on this.
Great. Thanks, Tony. And this sort of tees up a question I had as well. As the IMO addresses its greenhouse gas ambition, the big debate today in shipping is whether the IMO uses a tank-to-wake approach, placing the entire burden on shippers, or a more holistic well-to-wake approach. and incorporating the entire value chain, including low carbon and net carbon neutral fuels like methanol. For Kjeld and Tony, as engine OEMs, both Wärtsilä and MAN are fuel agnostic and are looking at all solutions. But would the IMO need to employ a well-to-wake approach to be technology neutral?
Kjeld, you go ahead. So.
Technology neutral. Could you rephrase that in some way?
So if the IMO is just approaching greenhouse gas emissions on a tank-to-weight basis, it's basically zero carbon fuels. So it's ammonia, hydrogen batteries. But on a well-to-wake basis, incorporating the entire value chain, you can look at net carbon neutral fuels like methanol and other biofuels. Yeah.
But my opinion is that you have to take the toll as it is the environment. It's what the environment actually feels and what we see on the increase in temperature. So you have to take everything into account to make a fair comparison of all the different fuels. And we are not going into this, as you also mentioned, as technology providers. We are listening to the need and from the market itself, and based on that, we take decisions of our development of fuel engines.
I mean, maybe a comment not relevant as an engine maker, because for us, it kind of does not make difference. But one is easy, and the tank to wheel is easy, and what's easy is it's usually the preferred way to do things. Everybody would like to take the easy way, and you can always measure your tank to well, from tank emissions instead of well. The other one is more complex because it will include other industries, and I'm not sure how much IMO could regulate or can actually gather data from the emissions from the origin of the fuels. And it's much more complex, but for the society and for all of us as citizens in this world, and for our kids' future, of course, it's the total emissions which does apply.
And Anita, when you talk about methanol pricing, and I kind of teed this up in my presentation a little bit, there's now growing support for a carbon tax on diesel marine fuels. Would such a tax serve as an incentive for the use of methanol as a sort of a bridge from fossil to renewable fuels?
Yeah, yes, it will. I mean, we looked at some numbers internally, and it does make methanol competitive when compared to alternatives and to marine gas oil, well, and any crude-based fuel really. So we definitely think that in order for alternative fuels, biomethanol, gray methanol, any alternative fuel to have a future, you're going to have to implement some form of carbon taxation, because in reality, green fuels are more expensive to manufacture at this time.
And if such a carbon tax was based on the carbon intensity of a fuel, could that also be an incentive for blue methanol? There's a point here that, if you look at Southeast Asia, Middle East, where there's a lot of resources for solar and wind power, you could see the addition of green hydrogen to methanol or natural gas-based product and kind of reduce its footprint and produce blue methanol. Do you see some demand for blue methanol in the marine industry?
Most definitely, and especially to help with that transition, to assist with the transition over the next 20 years, I see the need for it.
I do want to give Simon a moment to close, but Kjeld, Tony, or Anita, do you have any closing thoughts you'd like to share?
I just want to mention that based on what we see the last 2 years, and maybe also especially after the announcement from AP Møller that they are now going to use methanol on a non-carrier or non-carriers, the interest have really increased. I really believe that there will be a big market for methanol and green methanol in the future. And the technology on the engine side, you have heard, both on 4-stroke and 2-stroke is there.
And maybe, I mean, what I always emphasize is seeing methanol as a hydrogen carrier, and there is no other medium that is liquid at atmospheric pressure and temperature that will displace less volume than methanol containing hydrogen. So methanol is really easy to store in ships and to handle as well. Any leakages can be diluted by water. Just spray water on it and it becomes harmless. So it is much easier. And if you breathe it, I mean, if you breathe the vapor of methanol, not much will happen to you compared to maybe other fuels.
And Anita?
You know, I think the future for methanol is limitless. I've seen that interest increase over the last year in conferences, and I agree with everything that has been said. Methanol is safe to handle, it's easy to store, it's easy to carry. The engine technology is proven already, it's being used. I mean, 11 vessels, tankers already sail with methanol. Another 14 vessels will be added to the fleet within the next 2 years. And you know, why not methanol? You know all the reasons why it makes sense. The capex is lower than LNG. I think it's the fuel that will be the pathway fuel. And I think for the medium term, we can use gray methanol, blue methanol, and we will scale up to meet the green methanol requirements by 2050. So.
Great, thanks, Anita. And from my perspective, I think there's also the need to act now. I mean, we can't wait another decade for technologies to catch up. Methanol is available today. As we've heard, they're mature engines are available now. The fuel is available today. The infrastructure is affordable. So we can act now. And methanol also being the solution for both new builds and retrofits. So let's also think about those 90,000 vessels that are still on the water today with the potential for retrofit to methanol. And with that, I want to thank Simon again and Clean Shipping International for facilitating this webinar. And Simon, if you have some final thoughts you'd like to share.
Well, just to say, to thank you, Greg, Anita, Keld, and Tony, for some very informative and interesting presentations. I think we all gained a lot this afternoon, and thank you all of you for joining us. Just to say, you'd be very welcome to join us for our other clean shipping webinars. We're planning a number of others looking at alternative fuels and scrubbers. These will be scheduled depending on holidays and speaker availability. So do keep a regular look out at the website for dates, and of course we'll doubtless mail shot you all the details as well. Now the dates are subject to change. We're going to have to shift a few dates around, I think, due to speaker availability. But we look forward to seeing you all again, and enjoy the rest of the day wherever you all are. Many thanks. Cheerio then.
Thank you.